October 4th, 1957. A 183-pound aluminum sphere with 4 whip antennas starts beeping over Baikonur, Venus, and that beep is picked up by radios all over the planet. That's Sputnik 1, humanity's first artificial satellite, and its signal alone is enough to trigger a space race. Now fast forward, decades after that first beep, we'd build a spacecraft and send it diving straight into the sun's own atmosphere, closer to a star than anything humans have ever flown. From a beeping sphere to touching a star, that's the entire story of space exploration, and we're about to fly through all of it in 11 minutes. So rewind with me to 1957, to a modified R-7 rocket lifting off from Kazakhstan, carrying the object that started everything. Welcome to Cosmic Doodles. Draw a little rocket in your mind, because we're building a timeline out of tiny machines that went where no human has ever set foot. Back to that sphere. It's 10:29 p.m. Moscow time, and a modified R-7 rocket climbs off the pad at Baikonur. Riding on top is Sputnik 1 Venus, a polished aluminum ball just 58 centimeters across, 83.6 kilograms, or about 183 pounds, trailing those 4 long whip antennas, the longest stretching nearly 3 meters. That's it. No cameras, no science lab, just a radio transmitter and a beep. But that beep circled the Earth once every 98 minutes. Over its life, it completed around 4,200 orbits and traveled roughly 70 million kilometers before its orbit finally decayed on January 4th, 1958. 92 days after launch, and in those 92 days, it changed history. The West was stunned. If the Soviets could put a beeping ball over every city on Earth, what else could they put up there? That single shock led directly to the creation of NASA in 1958 and a massive surge in American science and education spending. One little sphere, one little sound, and the modern age of exploration was born. Now the race is on, and the next target is another planet. Fast forward to August 27, 1962. NASA launches Mariner 2, and it sets off on a 110-day, 182-million-mile cruise toward Venus. On December 14, 1962, it slips within 21,648 miles of the planet and becomes the first successful planetary flyby in all of history. It only had 42 minutes to scan Venus as it swept past, but what a 42 minutes! Before Mariner 2, some people still imagined Venus as a warm, swampy sister world, maybe even dripping with jungles. Mariner 2 killed that dream. It clocked surface temperatures of 300 to 400 degrees Fahrenheit, confirming a runaway greenhouse effect that a young scientist named Carl Sagan had predicted. It found atmospheric pressure around 20 times Earth's, detected no real magnetic field, and along the way made the first direct measurements of the solar wind, that constant stream of particles blowing off the sun. Venus wasn't a paradise, it was a furnace. And we'd only just started learning how hot, but before anyone landed anywhere, someone had to prove you even could. Enter Luna 9. On January 31, 1966, the Soviets launch it from Baikonur, and on February 3rd, it does something no machine had ever done: Venus. It survives the trip down and gently comes to rest on the surface of another world, in the moon's Oceanus Procellarum, the ocean of storms. The first soft landing in history. Picture this. After bouncing to a stop, the little capsule unfolds 4 spring-loaded petals, like a metal flower opening, to right itself. Then a rotating mirror camera swivels around and beams home the very first photographs ever taken from the surface of the moon. Suddenly, the lunar ground wasn't a theory. It was a place, with rocks and shadows and texture. Luna 9 beat America's Surveyor 1 to the punch by about 4 months. Contact was lost on February 6th when its batteries finally died Venus, but by then it had already opened the door. The moon is one thing, landing on another planet is a nightmare Venus, and no planet is a worse nightmare than Venus. So here comes the bravest little machine on this whole list, Venera 7. On December 15, 1970, this Soviet probe becomes the first spacecraft ever to soft land on another planet. And understand what that meant. Engineers built Venera 7 to survive pressures up to 18 megapascals and temperatures of 580 degrees Celsius Venus. They were designing a craft to be crushed and cooked at the same time. On the way down, its parachute failed and it hit the surface in freefall, tipping over onto its side. By all rights, that should have been the end, but engineers combing through the data later pulled out about 23 minutes of faint, ghostly transmissions from the surface, a whisper from inside hell. And that whisper confirmed it: the crushing heat, the immense pressure, an atmosphere roughly 97% carbon dioxide. Humanity had touched the surface of another planet, and the planet had done its best to destroy the messenger. Now we go outward, way outward. March 2nd, 1972, an Atlas Centaur rocket sends Pioneer 10 on its way, and this one is all about firsts. It became the first spacecraft to cross the asteroid belt, that swarm of rocky debris everyone feared would shred anything passing through. It didn't. Pioneer 10 sailed on and became the first spacecraft to fly past Jupiter, sending home the first close-up images of the giant planet and its moons. At just 258 kilograms, this modest little probe also became the first human-made object ever to reach solar system escape velocity, meaning it was moving fast enough to leave the sun's grip entirely and never come back. We had officially thrown something at the stars. Meanwhile, we still hadn't stood on the surface of Mars. That changes on July 20th, 1976. Viking 1 had launched almost a year earlier, on August 20th, 1975, slipped into Mars orbit that June, and now its lander is dropping toward the Martian plains of Cres Planitia. At 7:53 a.m. Eastern Time, it settles onto the surface, the first U.S. spacecraft ever to land on another planet. And Viking wasn't just there to snap postcards. Its objectives were huge: high-resolution imaging of the Martian surface, detailed studies of the atmosphere and soil composition, and the headline biology experiments designed to search for evidence of life itself. Viking scooped up Martian dirt and ran chemical tests looking for the fingerprints of living things. The results were famously ambiguous, and scientists still argue about them. But the lander itself was a champion, operating all the way until November 1982. More than 6 years on the surface of Mars, sending home a world. And now we reach the two most famous machines ever built. On August 20th, 1977, Voyager 2 launches. About 2 weeks later, on September 5th, its twin Voyager 1 follows. Both of them carry the same haunting cargo, a 30-centimeter gold-plated copper disc called the Golden Recordness, a message in a bottle thrown into the cosmic ocean. On it are greetings in 55 languages and 35 sounds of life on Earth, from birdsong to a mother's kiss, all meant for whoever, or whatever, might find them a billion years from now. But before they left, the Voyagers rewrote the textbooks. Voyager 1 discovered a thin ring around Jupiter, spotted 2 new Jovian moons, Thebe and Metis, and found 5 new moons of Saturn, plus Saturn's faint G-ring. Then they kept going. On August 25, 2012, Voyager 1 crossed the heliopause, the boundary where the sun's influence ends, and became the first spacecraft ever to enter interstellar space. Voyager 2 crossed over on November 5, 2018. And here's the part that gives me chills. Voyager 1 is still talking to us. It's down to just 2 still working instruments now, a magnetometer and a plasma waves experiment. The others switched off one by one to save its dwindling power maintenance, but through those 2 it keeps whispering back across billions of miles to NASA's Deep Space Network. Launched before most of us were born, and still on the job. Back at Jupiter, we decided flying past wasn't enough. We wanted to go inside. NASA's Galileo launches from the cargo bay of Space Shuttle Atlantis in October 1989, spends 6 long years cruising out to the giant, and enters orbit on December 7, 1995. But Galileo had a secret weapon, a 339-kilogram atmospheric probe, released that July. On that same December day, that probe did the unthinkable. It plunged straight into Jupiter's clouds, where no parachute could save it, just deeper and deeper crushing gas. It transmitted for about 58 minutes, falling through roughly 165 kilometers, before the heat and pressure finally tore it apart, the only human-made object ever sent into Jupiter's atmosphere. In its final minutes, it beamed back about 3.5 megabits of data and found less helium and much drier conditions than anyone expected. A machine that died to send us a weather report from inside a gas giant. Then we did it again, this time on a moon. The joint NASA and ESA mission Cassini-Huygens launches on October 15, 1997, and reaches Saturn on July 1, 2004. Riding along was the European Huygens probe, aimed at Titan, Saturn's giant moon, wrapped in a thick orange haze no telescope could see through. Huygens separated on Christmas Day 2004, and on January 14, 2005, it parachuted down through that haze for 2 hours and 22 minutes, thumping onto the surface at 4.54 meters per second, meaning the first landing on any world beyond Mars. And what it found under that haze was staggering, roughly 350 images over 72 to 90 minutes, revealing shoreline erosion and what looked like a river delta. A world with weather, with liquid, with landscapes carved by flowing rivers just made of freezing hydrocarbons instead of water. And Cassini, still orbiting overhead, went on to confirm liquid hydrocarbon lakes on Titan and towering water ice geysers erupting from the little moon Enceladus. Alien oceans, hiding in plain sight. Landing on a planet is hard. Landing on a comet? That's borderline insane. ESA's Rosetta launches on March 2, 2004, and then chases its target for 10 years, finally catching comet 67P Heaven Venus, a lumpy, rubber duck-shaped mountain of ice and dust Venus, on August 6, 2014. On November 12th, it releases a small lander called Philae, which drifts down for 7 agonizing hours before its touchdown signal reaches Earth at 16,003 GMT. And then things go wrong in the most dramatic way. Philae's harpoons fail to fire, so it can't anchor to the low-gravity comet, and it bounces. It skips across the surface and comes to rest in a shadowy spot called Abydos, where it couldn't get enough sunlight. On November 15th, with its batteries drained, it slips into hibernation. But this is a comeback story. As the comet swung closer to the sun in June and July of 2015, more light finally hit Philae's solar panels, and for a brief, beautiful moment, the little lander woke up and phoned home from the surface of a comet. By now, we'd visited nearly everything except one lonely little world at the edge. New Horizons launches on January 19, 2006, uses a gravity slingshot around Jupiter to pick up speed, and then falls silent for nearly a decade of cruising. 9.5 years and about 3 billion miles later, on July 14, 2015, it screams past Pluto at just 7,800 miles. The closest look humanity has ever had at the last classic unexplored world. It had roughly 30 hours around closest approach to make 236 science observations, and it worked frantically, snapping the frozen heart-shaped plains and icy mountains that turned Pluto from a fuzzy dot into a real complicated place. Then came the patience. Sending all that data home across 3 billion miles took roughly 15 months, dribbling back one precious image at a time. Which brings us all the way back to that opening promise. On August 12, 2018, NASA launches the Parker Solar Probe, meaning a spacecraft built for the single most audacious target of all, the Sun itself. Hiding behind a carbon heat shield that endures temperatures near 2,500 degrees Fahrenheit, Parker plunges again and again toward our star, and in 2021, it became the first spacecraft to fly through the corona of the Sun's own outer atmosphere. On December 24, 2024, it made its record-breaking closest pass, skimming just 3.8 million miles above the Sun's surface. And to survive that dive, it whips around the Sun at speeds up to roughly 430,000 miles per hour, the fastest object humans have ever built. In a single lifetime, we went from being afraid of a radio signal to reaching out and touching a star. So think about the whole arc. Sputnik 1 was a metal ball that could only beep, and it terrified the world. And out there right now, Voyager 1 is still transmitting from interstellar space, carrying a golden record of who we were, whispering back to a species that started all of this with a single sound over Baikonur. From a beep to a star, that's us. That's what we do. This has been Cosmic Doodles, and here's your homework. Draw that little rocket one more time, aim its nose at whatever's next out there, and dream up where we send it. Because someone doodled every one of these machines first, too.